Welcome to solverfy.
This is chapter 27, problem number 52. We are given a charge under an external magnetic field. It experiences a force, and we are to calculate the x, y, and z components of this force. So the magnetic field is given to us as it's purely along positive x direction as 0.65 Tesla I hat, which means our dx is 0.65. Y component is 0 and the z component is also 0. And also the velocity vector, the components of the velocity vector along with the directions are given. Negative 1.68 times 10 to the power 4 meter per second I hat minus 3.11 times 10 to the power 4 meters per second j hat plus 5.85 times 10 to the power 4 meters per second k hat. Now, in order to calculate the force, as you know, the force is going to be equal to Q times V cross B. Then it equals to I hat, J hat, K hat, Vx, Vy, Vz, Bx, By, Bz. Now, Q I hat, then it's going to be equal to Vy, Bz minus Vz, By minus J hat, Vx, Vz minus Vz, Bx plus K hat, Bx, By minus Vy, Bx. This is going to be equal to Fx, the x component times I hat, y component of the force times j hat, z component of the force k hat. So then each term, q times this, for example, is going to give us the x component, right? And q times this term is going to give us the y component of the force. Q times this term is going to give us the z component of the force. Now, on your page, let's write down then what f sub x would be. It would be equal to Vy, Bz minus Vz, By times Q. Let's remember what Bz was. It was 0, making the whole term 0. By is also 0, so the x component of our force comes out to be 0. The y component looks like negative Q times Vx, Bz minus Vz, Bx equals, well, Bz is 0, so the first term drops. Then we're left with Q, Bz, Bx. If we plug in the values, 7.26 times 10 to the power negative 8 coulombs times 5.85 times 10 to the power 4 meters per second for the z component of the velocity vector times the magnitude of the magnetic field, 0.65 Tesla. If we do a calculation, what we find is 2.76 times 10 to the power negative 3 newtons. Now, let's do the last part. F sub z would be equal to Q Bx By minus Vy Bx. Vy is 0, so the first term is 0. We're left with only the second term times Q. Negative Q By Bx then would be negative 7.26 times 10 to the power negative 8 coulombs, negative 3.11 times 10 to the power 4 meters per second times 0.65 Tesla. Then we find the z component of the force to be 1.47 times 10 to the power negative 3 newtons.